Hey guys, so this is the breakdown of the project, the studio edit. Also, the old title, The Room of My Own. So, the core objective for this project was to unfold the abilities of using USD in production. In modern 3D production, artists frequently encounter software friction, converting FBX files, exporting LMBEX, and having different file formats for different applications. Manually rebuilding shaders in every tool and losing lighting patience across engines. For this master's project, my research centered on breaking down those priority walls. I wanted to establish an end-to-end environment pipeline driven by USD and Material X. The major benefit of using USD is that it allows you to use different DCC applications without having different file formats. So in theory, you should be allowed to use a single file format which you can use across different platforms. This testing was specially focused on how small studios can utilize USD pipeline technologies in their own production workflows. So in this project, I created a pipeline around USD to develop the studio edit. The origin of this idea came across when I wanted to build my own portfolio video and wanted to express myself and my hobbies and my interest in my portfolio itself while showing my work and my skills. The initial idea was to have my own personal space with my own belongings in a bedroom with a workstation nearby to showcase all my achievements and my personal hobbies together. But the concept and the script later evolved to having my own personal studio. Hence, the project earlier was named Room of My Own, which later got converted into the studio edit. Rather than treating this purely as an environmental showcase, every single prop and lighting fixtures were approached with a non destructive data exchange in mind. Let's look under the hood to see how the pipeline was constructed. Instead of traditional file structures where the scene lies solely into one master file, I structured this project, the Studio Edit, around the layered USD composition. This made the entire workflow non-destructive and in a layered-based composition where objects could be laid on different layers with the different properties. This architecture relies on non-destructive override. Base geometries reference are kept lightweight while separated payload handles high resolution details, collisions, primitives, and variant set. Even though I did not utilize the full capacity of variant sets in this project, while I face some issues around Arnold and Blender having shader complexions and difficulties understanding USD shaders, I lean towards going and developing Material X as my shading language in USD. Problems started coming up when I tried to keep the project on open source tools like Blender, as USD itself is an open source project by Pixar. But I later came across a limitation of Blender that it does not fully support USD yet, as it does not have an USD stage layer editors and it does not support variant sets. It can just be used to import USD files and export USD files with materials while facing limitations in the number of shaders and the nodes allowed in look development. Hence, I shifted my focus towards Houdini, which allowed me to use Solaris, which itself is built on USD. And I also used Maya with its own LookDevX, which supports Material X materials and Material X nodes. Because the material pipeline was based on Material X, this allowed me to use AMD's own Material X library, which has a lot of PBR materials ready to use, and they are just one click import, which made my life a lot easier and faster in production. So when building out the assets, I utilize the strength of specific DCC tools rather than focusing together on a single application. I used Maya for blocking out materials and also used Blender for modeling and Unreal as my main rendering engine. Initially, I did face a lot of issues while I was translating all the part tracing materials into an real-time engine. I faced a lot of problems while developing materials like glass, but those issues were resolved after utilizing Material X. Because the file formats were in USD, it allowed me to use Unreal as my real-time render engine while utilizing my other DCC applications without hassle, and have a single file which also allowed me to save a lot of storage space and allowed me to work on a low configuration machine without costing a lot of storage and performance bottleneck. This also created a lot of problems while I was following the USD pipeline, as I was used to the traditional workflow. I kept editing the files and the layers on the top, which override the functions and the materials on the layer below, creating a problems while I was updating the files, but they were not showing up in the final output. But after cleaning the files up and getting used to the USD pipeline and its layer based system, it allowed me to utilize it in a real time render engine and do lighting and look development at earlier stages while blocking out the entire section of the rooms. This got me carried away a little while utilizing Unreal's real time render engine, and I ended up spending a lot of time perfecting small things, which consumed a lot of time compared to when I'm focusing on a specific asset, and it was too addictive to work with it. This allowed me to utilize Unreal Engine's camera settings while previewing the animation in the blockout phase. This influenced me and allowed me to make a lot of changes even at the later stages of the project to modify the layout of the room and the structure. Without disturbing the entire file, I was able to make changes with USD's layer-based stage system. The first asset and the hero asset for the entire film was my drum set, which I had modeled using Blender. This model later got translated into Maya for look development and then was later sent for texturing in Substance Painter. Even though Substance Painter does not support USD exports, but it allowed me to export textures which I could utilize in Autodesk Maya to use LookDevX and Material X to develop materials. As I wanted to utilize the most out of Unreal Engine 5.8's ability, I also used motion capture to animate my Unreal Engine character and also got a photo scan of myself to develop my own MetaHuman. Because I was utilizing MetaHuman, I was restricted to work in Unreal Engine with it, and I did not use USD with MetaHumans. But I was able to utilize Clo for developing clothing for my MetaHuman characters, and I used Clo's USD export feature and Unreal Engine's Chaos Cloth to develop outfits for my MetaHuman character. Initially, the project was based on 5.7, which had a lot of bugs and issues and problems while importing the USD from exported from Clo inside Unreal, causing a lot of simulation glitches while wearing clothes. But as 5.8 had recently released and under Annabeth's guidance, I was able to utilize 5.8, which was much more stable compared to 5.7 for developing clothes using Clo and Unreal Engine for my MetaHuman. As I started animating, I wanted to utilize the motion capture tools which were available to me. So I got in touch with Colin and Glenn to have an motion capture and utilize that motion capture to have some basic movements like walking, sitting, and opening car doors. This is where the motion capture gloves helped me a lot. It was quite a new experience while doing the motion capture. And thanks for Colin for cleaning up a lot of the data in the background so that I could directly use these files inside Unreal Engine. Then I started with the animation process and I made a lot of changes in the room's layout after setting up the camera. So I had in total of around 3 to 4 changes in the room layout, with the major change being in the stairs moving from the right side of the scene to the left to have more open space and a clear view towards the workstation. Even though these were a lot of major changes done in the room's layout, I was able to utilize USC and its layer based function to do it non destructively while keeping other things preserved in the entire scene graph. While doing my animation, I utilized a lot of AI tools like 11 Labs to develop a temporary voiceover before the final audio production, which helped me across setting up the timing chain across the entire sequence and helped me animate before the audio production begin for the entire process. Also, during audio production, I came across a tool which helped me and allowed me to simulate actual engine sounds with their configured engines. And I was able to find the engine for the exact car model which I had in mind. And I utilized that to simulate the engine sounds and got it in the final audio production with help of Kanisha. Thank you for watching.